Hello everyone, this is Mrs. Rivas. So here we're just focusing again on things that you learned on the unit circle. You should have created the unit circle by now. Remember that unit circle is going to be very important throughout this entire unit, and it's really important even in calculus. So if you look at the calendar, you do have quizzes every day on that unit circle after the Christmas break. So that's going to be your main homework over the break, is making sure you memorize that unit circle. Every time we're going to be adding on a color, and they're going to be timed quizzes. Okay? So here we're focusing on the radian measure, and more importantly, how to go from degree to radian and radian to degrees. So it emphasizes that 360 degrees is the same as 2 pi. So 2 pi equals 360 degrees. If I were to divide by 2, then I can see, okay, 1 pi is equal to 180, and that's where that comes from. On the unit circle, if I divide that by 2, then I can see I can get, pi over 2 is equal to 90 degrees. Okay, and again, these are all angles that are on your unit circle. So yes, you have to know the degrees, and you have to know the radian, more importantly, the radian, because a lot of things start becoming just in radian, not degrees anymore. So one thing that's going to be important on your homework, and we'll do a couple problems together, is you have to be able to go from degree to radian and radian to degree. If you're going from degree to radian, one way to do it would be to multiply by pi over 180. What you're trying to aim for is what goes on top. If we're trying to go from radian to degree, then I would multiply by 180 over pi. Okay, alrighty. So again, this is part of your unit circle. It's all the angles. If you want to think of the pi's, because remember, what is pi? Pi is 180. So if you forget, think of this as 180 divided by 6, because pi is equal to 180, which is 30 degrees. 180 divided by 4 is 45 degrees. 180 divided by 3, 60 degrees, and so on. So even if you forget, that's one way to go ahead and figure it out. And on your unit circle, I think by now you figured out all of these are going to be the same distance away. That's why they're all the same color. These are all 30 degrees away from the x-axis. So if I know all the way around is 360, take off 30, this makes this one 330. Or if I know halfway is 180, I go up, meaning I'm subtracting 30. 180 minus 30, that makes this one 150. Or if I add 30, because I'm increasing, plus 30 would make this one 210. Okay, and they're all going to be the same based on that specific one. That's why they're color-coded, the ones that go together. Here is to use the special right triangles. You actually saw these for the very first time in geometry, so they should look familiar. If they don't, it's okay. But that's another way to help you if you're confused on the angles. All right, so let's take out some paper so we can look at the homework. So if we need to pause the video to get prepared. And we're going to do a few together. I want to look at part of number 1. So number 1's asking us to indicate each angle on a circle. So I'm going to draw a circle. And remember, this is quadrant 1, 2, 3, and 4. And the first angle wants us to indicate is 60 degrees. This is about 60 degrees. It's more than halfway. That's 45. 280. If it helps, I'm going to label each quadrant. Quadrantal angles 0, 90, 180, 270, and of course all the way around is 360. So the next angle is 280 degrees, which is right after 270. It's about right here. The next one is negative 225. So a negative angle I'll put it here to the side, means you're going to go in an opposite direction. Negative angle goes clockwise instead of counter. So if it helps, first think, if I were to do regular positive 225, it would be between these two. Okay, and if you think about how far is 225 from 180, that's 45 degrees, so it's right in the middle. So I'm just going to draw a dashed line. This would be positive 225 degrees. So notice how much I traveled. One quadrant, second quadrant and a half. 1, 2.5. So I'm going to travel that same distance, but going clockwise instead. So it's 1 quadrant, 2 quadrant and a half. So we end up landing here, and this is negative 225 degrees. So if it helps to think of it as a positive, see how much you're going around, and then go in the opposite direction, then do that. The next one in degrees is 10 degrees, somewhere here. And then I'm going to put all the other 2 radian on a separate picture so I can label the corners. This is 0, pi over 2, pi, 3 pi over 2, and 2 pi. All the way around. So 7 pi over 6. And I'm going to write it to the side, because you have to be able to do this without changing it to radian. So the first thing I notice, 7 over 6 is bigger than 1. Okay, so for sure it's bigger than a pi. Okay, so think of this as 1 pi or 6 pi over 6 plus 1/6 pi. So it's going to be about somewhere here, and that's one that's on your unit circle that you need to know. The next one is 9 pi over 4. Again, just focus. I'll forget the pi. Forget the pi itself. Just focus on the value. 9 over 4. 9 divided by 4 is bigger than 2. That tells me it went all the way around, because that's 2 pi, and some extra. So if I want to figure out how much extra, I'm going to subtract 2 pi. We know in order to subtract fractions, we need common denominators. So I'm going to multiply the top and the bottom by 4. So we have 9 pi over 4 minus 8 pi over 4. So that tells me I went a whole circle, 2 pi, all the way around, plus an extra quarter, 1/4. So about right here is 9 pi over 4. And one thing I should have been doing was showing the travel all the way around and ended up here. If I do the other one just went there. Okay, so that's what it means by indicate each angle. And don't forget, there is some part of a key online to the odd problems. So the next one I want to look at is converting. And I want to focus on converting from radian to degrees. So let's look at number 5. Number 5 is asking us to convert 2 pi over 3 to degrees. So we're going to have to multiply by 180 over pi. Because the pi's are diagonal, I can cross them off. So if we go across, we would have 2 times 180 divided by 3. I can simplify this. 180 divided by 3 is 60. Forgot my degree symbol. So our answer is 120 degrees. So part of your Canvas is going to be able to convert. And again, on the test, you don't get to use a calculator, so you have to be able to do without. Another section would be, let's say, in the opposite direction. So let's look at number 9. You're looking at converting the angle 280 degrees to radian. So you multiply by the reciprocal of that. Pi over 180. So this gives me 280 pi over 180. We can divide the top and bottom by 10. And I can go ahead and divide the top and bottom, let's say by 2. Let's see if we can simplify it more after that. Half of 28 is 14, and half of 18 is 9. I look at this, there's nothing else I can do. I forgot my pi. So that's my answer, 14 pi over 9. So that was number 9. Let's look at the next section where we're looking for coterminal angles. So coterminal angle, just to make sure we know what that means before we actually do an example, is think of it like there are multiple angles that have the same starting point. So I'll write that on here, angles that have the same starting point, the same start and stop. Okay, so if I were to draw a picture of that, what do I mean by that? Say I'm going to 135 degrees. It's right here. I can go counterclockwise. That's one way to go. Another way would be if I go in the opposite direction. Okay, that would be negative 225 degrees. They have the same start. This is where I'm starting. And over here is where I'm stopping at this point. Okay, they just went in different directions. Another way to go, which I know kind of seems, or it's going to seem, why even do that, but it's an option, is to go all the way around and then more. They still have the same starting point. They still have the same stopping point. So all of these are considered coterminal angles. So your goal on what it's asking is they're giving you angles that are way bigger than 0 and 360, bigger than that range that they're giving you. So they want you to find one until you get a value between 0 and 360. So if it's too big, you subtract it. And think about if I told you turn around 360 degrees, what happens? You end up in the same spot. So a shortcut of finding coterminal angles is to add or subtract 360 degrees, or add or subtract 2 pi radian, depending what they give you, okay? So let's look at, let's say, number 11. So the angle they're giving you is 645 degrees. So I look at this and right away I see it's way too big, bigger than 360. So I'm going to subtract 360 degrees. Again, you don't get to use a calculator, so practice not using one. So we get 5, we have to borrow. 14 minus 6 is 8. 5 minus 3 is 2. So we get 285 degrees. And that's it. That's your answer. Why? Because it's between 0 and 360 degrees. Now let's do one that, let's do a radian one. And real quick, if you look at 13, and I'll write it down. 13 is negative 1,682 degrees. Because it's negative, we're going to have to add 360. But it's really big, so you're going to have to keep going, add another 360, add another, until you get an answer between 0 and 360 degrees, okay? So just wanted to point that out there. Let me go to the next page. So say we're looking at number 15. That one's in radian. And we have 23 pi over 9. So I look at this, the first thing I need to decide, is it too big or too small? Too big. Because I know it's too big, because for 2 pi would be 18 over 9, because 18 divided by 9 is 2. Bigger than that. So remember what we said, we either add or subtract 2 pi. So I'm going to have to subtract 2 pi. I can make anything look like a fraction, put it over 1. We need common denominators, multiply the top and bottom. So now we have 23 pi over 9 minus 18 pi over 9. So here we subtract 23 minus 18, we get 5. Is that between 0 and 2 pi? Yes, it is. And there's your answer. So that's what you're doing mainly for most of that homework. There is another, the very last page of it, 19 through 22. You're given a function and a specified quadrant it's in. Find the other trig values. So I'll do one of those with you. And I want to do number 21. So it's giving you cosecant, and it's negative 25 over 24. And it tells you that the angle is between pi and 3 pi over 2. So of course, what I'm going to do is draw a picture. This is 0, pi over 2, pi, 3 pi over 2, all the way around is 2 pi. It's telling me between pi and 3 pi over 2. So my angle's somewhere here. So what I do, start from the origin, make a segment coming out, and then draw a line perpendicular, makes 90 degrees with the x-axis. Always with the x-axis, not the y. Always with the x-axis, not the y. Your angle A, your angle of interest, is always the angle it makes with the x-axis. Always. Okay? Now we're going to label it. Cosecant, remember, cosecant is the reciprocal of sine. And by now I hope we remember SOHCAHTOA. Sine is opposite over hypotenuse, so that means cosecant is hypotenuse over opposite. So my hypotenuse is 25, my opposite side is 24. I'm sure you noticed, she forgot the negative. The reason I didn't put it yet is because I need to make sure it makes sense with my picture. Think about what quadrant we're in. 1, 2, and 3. We are in quadrant 3. We know in quadrant 3, both the x and the y are negative. So that means the negative goes here and the negative goes here. Even though the negatives with the 25 doesn't necessarily mean it belongs to it. So the negative actually goes with the 24. And whenever I find my missing side, it's also going to be negative. Okay? So before I can list my other 5 trig functions that are missing, I need to use Pythagorean theorem to find my missing side. So a squared plus negative 24 squared equals 25 squared. And this is actually Pythagorean identity, but if you don't know it, it's okay. And notice I'm putting the negative 24 in parentheses because you know if you square anything, it's always positive. So once you do that, we should get 49. So A is equal to 7. But remember, we're in quadrant 3, so actually my missing side is negative 7. So that's why it was important that they gave you this information on where the angle lands. Okay? Now that my picture's drawn, if it helps you to label, this is my opposite side, this is my hypotenuse, this is my adjacent side. So I need to find sine, cosine, tangent. I already have cosecant. I need to find secant and cotangent. So sine, opposite over hypotenuse, negative 24 over 25. I could have found that without drawing my picture because all I had to do was go to my original and flip it. Cosine is adjacent over hypotenuse, negative 7 over 25. Okay. Secant, you flip it, negative 25 over 7. And then tangent, opposite over adjacent, negative 24 over negative 7. Because it's double negative, we really don't need the negatives at all. I shouldn't have written them. So cotangent is 7 over 24. Okay, so that's what you're expected to do for the assignment. Alrighty, hope this helps.